This is a pretty exciting video. I'm going to show you all about for loops, how to create for loops. This is not about Fruit Loops, that weird sugary cereal that's probably pretty unhealthy for you. This is for loops. So the idea of a for loop is to repeat a set of statements, a set of code, multiple times, some number of times that you get to specify. And I'm also going to show you in this video how to create what's called nested control statements. That is, taking one control statement and embedding it inside another control statement. So let's start with a simple example here. So here we say for and end. Again, you see these reserved Matlab keywords. And here I have some variable that I set equal to some number or sequence. In this case, it's a sequence. So the conditional part of this loop is this vector that tells Matlab the number of times to repeat inside the loop and also the values of the looping variable. So this is often called the looping variable or sometimes the looping index. So here I specify that the looping variable should go from 1 to 10. So that means that Matlab is going to run all the code in between the for statement and the end statement. In this case, all the code is just one line. But of course, in practice, you might have many, many lines of code in here. So all of this code is going to be run 10 times. And each time Matlab iterates through running this code, it's going to change the value of this variable to according to these numbers that I specify here. So this is maybe a little bit confusing at first, because if you would just run this code here, that would actually produce a vector. So now we have this variable, counting variable, is a vector of integers 1 through 10. However, I'm going to run through this for loop and display, this is the disp function for displaying something to the command window. It's going to display the value of this looping variable each iteration, each time it goes through. So let's run all of this. And now you see that at each iteration, the variable, counting variable, is not equal to an entire vector. Instead, it's only equal to one value at a time. And that keeps incrementing. So it goes 1, 2, 3, 4, and so on. Now, this also means that you do not need to explicitly update the value of this counting variable. So for example, you do not need to say counting variable equals counting variable plus 1. That's a little different from some other programming languages where you have to explicitly update the counting variable. So that is not necessary in Matlab. Matlab will do that for you. Now in this next example, I'm just showing you, I'm showing you two things. One is that you don't need to set these looping index variables to be increasing in just integers, in unit integers. They can also increase by 2. They can basically be almost whatever you want, although towards the end of this video I'm going to show you a common mistake that people make with for loops. So that was one thing I want to show you. The other thing that I want to illustrate to you in this example is that this looping index can be used in mathematical expressions. So here I am saying that, well, maybe I'll just run this code and then you'll see exactly what it says. Okay, so this says the first iteration value times 2 divided by 3 and added 7 is 7.667. So you see here that I'm using the looping variable I as a number in a mathematical expression. Now you can also see that this is incorrect. This says 1th, but this should say first. So this really should be ST. And here we have 3/3. This should really be third, and so this should be RD. And by the time you get to here, 5th, 7th, and 9th, this is starting to be correct. So that means that if you want to actually have some code that looks like this, where you're printing out, the ith iteration, you're going to need to do something else more than just this one line of code. You're going to need to adapt the code somehow to say, if the I is equal to 1, then this should say ST. And actually, that is exactly the hint for where we are going with this next example. So this is showing you an example of nesting control statements or embedding multiple control statements. So you already know about if-then statements, and now you know about for loops. And so here what we are doing is just combining these two concepts into one little paragraph of code. So we loop over 10 iterations, so all of this code gets run 10 times, and let's see what this code is doing. So this is saying if mod numi, and numi is this looping index variable here, comma 2 equals 0. So this is going to be our conditional. This is a Boolean statement. It's either true or false. Now what does this mean? So this is a mod function. It's short for the modulus. And the modulus is more commonly called the remainder. It's the remainder after division. So what the mod function does is divide the first input by the second input and return whatever is the remainder of that division. And so this is actually one way to determine the parity of a number. The parity of a number is just whether an integer is even or odd. So we say the modulus of this looping index here, which goes from 1 to 10, so this number divided by 2. And what is the remainder? Well, if the remainder of a number after dividing by 2 is 0, then it's an even number. And if the remainder is not 0, so it's going to be 1, then it is an odd number. And that's what we are basically testing here. So we loop through all of these, and then we test whether the number, numi, is even or odd, and then we print out that information. So the number 1 is odd, and that's the way the news goes, apparently. The number 2 is even, and so on up to 10. Now there's another concept about programming style that I would like to point out in this particular example. It is common to have looping indices use, or these looping variables to end in the letter I. And that's because that can act as like a key term for you to notice that the variable that ends with I is going to be the looping index. That's the I is for index. So you can have your looping index variable be something meaningful like num for number, and then I for index. That's useful because then when you see the variable throughout the rest of this here, you know that it's going to end in I, or you see that it ends in I, and then you know that that corresponds to a looping index. Okay, then I want to show you another embedding of multiple for loops here. So here we embedded an if statement in a for loop. Here I'm embedding a for loop inside another for loop. So what is happening inside this for loop? Well, we are looping over for I, so variable I equals 1 through 5, and then we're looping over variable j for 3 through 7. And then we say that the product matrix, so this variable matrix, and then the ith row and the jth column is equal to I times j, so the row index times the column index. So this illustrates multiple concepts here. One, it illustrates that we can use these looping indices both as indices into a matrix or vector, and also for mathematical expressions here. I'm also illustrating the concept that for looping index variables are often called I for the first one, and then the next one would be called j. Now, this arguably isn't such a great set of variable names. You remember I talked about variable naming conventions and guidelines at the end of the section on variables, and I said you should avoid using variables that are single letters. So in this case, I think it's permissible because the for loop is actually quite small. So it's not hard to see where the I and the j correspond to. If you had dozens or hundreds of lines of code inside these embedded for loops, then it would probably be better to use specific names. Maybe you could call this row I and call j, for example. Okay, so let me get rid of these things. And then there's a final concept to illustrate with this particular example, and that is that this variable actually doesn't exist. So I'm going to just select this text and press evaluate selection. Matlab says unrecognized function or variable product matrix. So I haven't yet created a variable or a matrix, in this case called product matrix, but I'm just creating it here on the fly. So let's run this code and see what we get. So the product matrix turns out to be, here we have all of the, so these values here, the row index times the column index. And what you also notice is that we start variable j, which corresponds to the columns here, we start it at 3, not at 1. And so MATLAB automatically fills in any missing values with zeros. That's important to know. MATLAB will fill in missing values with zeros. So we create this matrix on the fly. On the other hand, MATLAB is actually giving us this warning message here. So it says the variable assigned to, or the value assigned to product matrix might be unused. Okay, so that's actually, MATLAB is just telling us that, we're creating this variable and not using it anywhere else in the code. The error message that I actually want to show you is the second one, which reads, the variable product matrix appears to change in size on every loop iteration. Consider pre-allocating for speed. So MATLAB doesn't like that we are creating this matrix to be filled in on the fly. So as we go through these two embedded for loops, this matrix gets larger and larger. Instead, what we should be doing is something called initializing. So we are going to initialize this matrix. And it's common to initialize with zeros. So I'm going to use this function zeros. Here I specify the number of inputs corresponds to the number of dimensions of the matrix, and the value at each or in each input corresponds to the size, the number of elements along that dimension. So here I'm pre-allocating the matrix, the size of the matrix in MATLAB's memory. So I specify that the number of rows should be 5, number of columns to be 7, and then here I set this variable to be equal to all zeros. And then this is basically the same loop as I had earlier. And then there's another nice aspect of coding style that you can see in this example, and that is that the end statements have a comment afterwards, and I say end j loop because I call this j. And here I say end I loop, and I call this I loop here because I call the looping variable, the looping index here, I. So this is another example where, in this little toy example where we only have 5 lines of code, it's a little ridiculous to explicitly say, that this is the end of the j loop. It's pretty obvious here. But you can imagine that if you have hundreds of lines of code here, so lots of code in here, and maybe lots of code in here, and let's say there's another couple dozen lines of code here. Now it starts to get pretty useful to see what this end statement is actually corresponding to. So you look at this and you say, okay, this is the end of the j loop, and this is the code that needs to get run after we finish this j loop. So this is good programming style here. Now, there's one final thing I want to mention in this video, and that is a common mistake, a mistake that people commonly make when using looping for loops and looping indices that don't necessarily start at 1 or that don't go in integers. So here it looks like we are just creating a vector, and we want this vector to be populated with numbers that go from -3 to +3. Now, of course, in this example, you don't really need a for loop to create a vector that goes from -3 to +3, but I want to illustrate the mistake that is often made. And that mistake is that we are using this looping variable here, I, as an index and as a number. Now the problem here is that we're going to start by requesting the index of -3, and there is no index of -3. Indices must start at 1 with the first element. So if you like, I encourage you to pause the video and come up with a solution to this problem to get this code to work while still using a for loop. So as I mentioned, you don't really need a for loop here, but keep the for loop and just change the code so that it works as expected. Okay, so one way to solve this problem is to set this vector -3 to +3 as some other variable. I'll even call this other variable like this. So I say an other variable goes from -3 to +3. And now what should we set I to? Well, because we're using I as a looping index here, we actually want I to be integers that start at 1 and go up to the total number of numbers, the number of elements in other variable. So I'm going to say for I equals 1 to, remember I introduced you to this function length. So other length of other variable. So now here we are initializing the vector. And here I is going to go from 1 to 7. And then we still get our correct result, a vec. And this is going to go, oops, I made a mistake here. This was actually incorrect. What I really wanted to do, the way this should work, is say other variable. I'm sure you noticed that and were screaming at your computer screen for me to do the right thing. So now this is pretty interesting. We are indexing two different variables in two different ways. Here I'm indexing the variable that I want to assign this value into, and here I am indexing this vector here where I have the data vector that I want to specify. And now it should be correct. All right, so now we get this variable avec goes from -3 up to +3. Very nice. So we covered a lot of really great material in this video. I hope you found it useful and fruitful. So we covered for loops, that was the main thing. I also talked about several different aspects of programming style to make sure that your for loops look good and are sensibly written and easy to read. And I also introduced you to the concept of nested control statements, basically where you take one control statement and embed it inside another control statement. In the next video, I'm going to talk about while loops, which are pretty similar to for loops, but they differ in a subtle but important way. So I will see you soon.